Hi everybody, welcome to Mitch Maths. My name is Mitch and this video is going to be all about ratios. We're going to be going over what a ratio is, and I'm going to be showing you how you can simplify ratios, and I'll show you how that's just like fractions. We're going to be going over some scaling. So this is where if you have one actual size of one part of the ratio, you can find out what the other actual size is. We'll be going over proportional division. This is where you have the total amount, the actual total amount, and you can work out what the actual amount is of each part of the ratio. Then we'll also be covering the difference between two parts. This is where you can find out what the actual difference is between two parts of your ratio. Okay, so let's first think about then what actually is a ratio. So a ratio is usually shown as some numbers separated by a colon, just like this. And what it's representing is the proportion of one thing to another thing. And an example of where this sort of thing is used is something like cooking, where it's telling you how much of ingredients you need. So for example, with this one, it could be something like for every 7 grams of flour you need 3 grams of sugar. So they don't actually tell you the exact amount or the exact quantity. What they tell you is the proportion of one thing to another. So to simplify a ratio, what we can do is treat it almost exactly how we would do with a fraction if we were trying to simplify one of those. So we have two numbers here in our ratio, so we've got 20 to 24 as our example, and we want to simplify this to its simplest form. So just like we would with a fraction then, what we would do is look for common factors between both of these numbers. So if you're not sure how to do this with a fraction, then go check out one of my previous videos, but let's do it with this then. So what I talk about doing with the fractions is to always look for the easy examples. So we know that both of these numbers are even, which means that they can both be divided by 2. So if we divide both these numbers by 2 then, what we do, 20 divided by 2 gives us 10, and 24 divided by 2 gives us 12, okay? And we've simplified this one step. But of course, 10 and 12 are both even again, so what we can do is divide them by 2 again, and 10 divided by 2 gives us 5, and 12 divided by 2 gives us 6. Okay, so here we have our new ratio 5 to 6, and this is the simplest form of 20 to 24. Okay, do the exact same thing as a fraction, find the common factors and just divide through until we can't divide anymore and we get our simplest form. Okay, so I've got a couple more examples here of simplifying ratios. So one that involves decimals and one that involves fractions. So what we must remember with ratios is that all the numbers in our ratio must be whole numbers. So we can't have decimals and we can't have fractions. So how do we tackle these then? So let's look at the decimal example. We've got 1.6 to 2, okay, as our ratio. So what we can do here then is basically times these up so they become whole numbers. So as both of these have just one decimal place, what we can do is multiply both the numbers by 10, because this would give us 16 and 20. And here we go, we've now gotten rid of our decimals. We now have our whole numbers, which we can now simplify just like we did before. So treating this as a fraction again, if we try and think of a common factor of 16 and 20, I can think of 4. So we can now divide these both by 4. That gives us 4 to 5. And that is the simplest form of this ratio. All of them are whole numbers, and that's how you do that. Okay, so now moving on to our fractions example then, we want to turn this also into a ratio that has just whole numbers in it, just like before. So the way we can do this with fractions then is we want to turn these fractions into equivalent fractions that have a common denominator. So if we look at our example then of 7 over 4 and 3 over 2, we can look at the denominators of 4 and 2, and we want to find a multiple of these numbers. So a multiple of these could be 4, because both these numbers go into 4. So we can use that as our common denominator. So turning this first one then, it already has a denominator of 4, so they can stay the same. So we can keep 7 over 4, and we can double 2 to get 4. So then we must double the numerator and denominator. So this one can become 6 over 4. Okay, so now what we can do is we can multiply both sides by 4 to turn them both into whole numbers. So if we have 7 over 4 multiplied by 4 gives us 7, and 6 multiplied by 4 gives us 6. And that is how we turn our fractions into whole numbers for our ratio. We find the common denominator, just like this, and then multiply by that denominator to turn these into whole numbers. Okay, so now we're going to look at some scaling then, and now we're going to use our ratio to find the exact quantities of things. So the example that I've got here then is, so I have some apples and bananas in a ratio of 3 to 8, okay? I have 15 apples, so how many bananas do I have? Okay, so we have our ratio 3 to 8, and that shows us what proportion we have of apples and bananas. So let's lay this out really clearly then. So if we have our apples, okay, on one side, and our bananas on the other side. Okay, so our ratio is 3 to 8, so 3 apples for every 8 bananas. Okay, so we know that we have 15 apples, and we're asked to find how many bananas do we have, okay, with this ratio. So what we must do then is we must think, what do we multiply 3 by to get 15? Or in other words, what is 15 divided by 3? Okay, and that's 5. We multiply it by 5. Okay, so that means then we must also multiply our 8 by 5 to get our exact number of bananas. So 8 times 5 is 40. And that's the answer. So if we have 15 apples, we must have 15 bananas to keep our ratio of 3 to 8. Okay? A good way of checking if you've got the right answer here is to then simplify this back. And if you simplify this, you will get your ratio that you started with. Okay, and it's as easy as that, guys. You just look at what do you need to multiply one part of your ratio by to get the known quantity. Then you then multiply that by all the other parts of your ratio to get the exact amount that each of those parts represent. And this works if you have ratios with 3 parts, 4 parts, 5 parts, however many parts. You just multiply up the relevant part of your ratio up to your known quantity, look at what you multiplied it by, and then multiply that by all the other parts of your ratio to get the exact amounts of each. So now we're going to look at an example of proportional division. So this is where we have a total amount and we want to divide this up into a certain ratio. So the example I have here then is we have person A, B and C share £6,200 in a ratio of 1 to 4 to 9. Okay, and we want to find out how much money does each one get. Okay, so if we look at this ratio then, so all of the shares of these people, so all the amount of money that each one gets must add up to £6,200. And we know that if we look at our ratio, person A gets 1 part and person B gets 4 times what A has gotten, and person C gets 9 times what A has gotten. Okay, so let's find out what each one actually gets then. So what we must do is we must look at the total number of parts in our ratio. So in this example then, if we take our total parts, we just add them up. So we're going to have 9 plus 4 plus 1 to get the total number of parts. So 9 plus 4 is 13, plus the 1 gives us 14. Okay, so there are 14 parts in total that make up the 6,200. So now what we want to do is we want to find out what one part is. And if we look in our question, this will actually give us one of the answers. So we know that A has only got 1 part, so that will give us how much A has. Okay, so this will be 6,200 divided by 14. And let's just grab our calculator for that one. So we've got 6,200 divided by 14. And that gives us, so if we do this in pounds, this will give us £442.86. Okay, and that gives us 1 part. So that's 1 part. and that is how much A has gotten according to our ratio. Okay, so now what we want to do is we want to find out what B got. So we know they got 4 parts. So we know that for B, it must be 4 times what our 1 part is. Okay, so if we have our answer still on our calculator, we can multiply this by 4. So this gives us 1,771 and 43p. Okay, we've multiplied this by 4. Okay, so then now to the last little bit then, number C. So we know that C gets 9 parts of our total. So we know what 1 part is. So now what we must do to get C is multiply this by 9. Okay, so we take our start again. So we've got 442.86. Multiply this by 9. And that gives us 3,985 and 74 pence. Okay, and those are the answers to our question. And one way that you can check this is by adding them all up. And you know that if they add up to pretty much 6,200, you know you've got the right answer. So we've got our answer for C there, and we'll add the 1,771 and 43 pence, and then we'll add our £442 and 86 pence. And yeah, we've got a slight difference here, and that's just basically just because we rounded some of our answers halfway through. But these add up to 6,200, so we know we're on the right track, and we've divided them properly to give the exact amount that each one has got according to the ratio. So moving on to the last part of our video then, we're now going to be looking at questions that ask you about the difference between 2 parts of your ratio. Okay, so the example I've got here then says a string is cut into 3 pieces of lengths of ratio 2 to 3 to 6. Okay, so the first piece is cut 48 centimeters shorter than the third piece. How long is the second piece? Okay, so in this question, we are not given the exact amount of any of the pieces, and we're also not given the original length, as in we're not given the original total of all the pieces either. Okay, but what we are given is the difference between 2 of the pieces. So what we can do is then, we can look at how many parts of our ratio make up this difference. So in this example, we're talking about our first piece is 48 centimeters shorter than the third piece. Okay, so what we must now do is look at the difference in parts between the third piece and the first piece. So we can see from our ratio then that the third piece is made up of 6 parts and the first piece is made up of 2 parts. So the difference between these 2 lengths then in number of parts is 4. So what we can now do is we can now equate the difference in 48 centimeters is the same as these 4 parts. Okay, so from this we can work out how much 1 part is. So 1 part will now be equal to 48 divided by 4. Okay, and that will be equal to 12 centimeters. And now we know how long 1 part is, we can now work out the exact length of any of the parts. Okay, so the question asks us for the second piece. So this is 3 parts. So 1 part is 12. So the second piece length is 12 times 3. And that equals 36 centimeters. And that is the answer to that question. If we wanted to work out the lengths of the other parts, we can do that as well. So the first part is 2 parts worth, so that'd be 12 times 2 is 24 centimeters. And the third part is the longest bit, because that makes up 6 parts of our ratio. So 6 times 12 is 72 centimeters, and that'll be the exact length of that part as well. And if we added those all up, we could then find the total length of the string at the start. and we could do anything we want with it, really. So I think the most important thing with these sort of questions with ratios is always working out how much one part is. As soon as you work out how much one part is, you can then times that up to give us how much or how quantities or anything like that of any part of the ratio. Okay, I hope that made sense, guys. I hope you really enjoyed the video. If you want to go and see more videos from Mitch Maths, then go and check out my YouTube channel and my website. And like and subscribe this if you found it useful, and I'll see you in the next video. Thank you very much.